About the weather. And Miss Gina printed off a sheet on here. Let me see it. Let me share it with Xavier.
Just stand up. Fine.
Xavier, can you see this? Can you see that? This is two thermometers, and this one shows the temperature way up, which would be the temperature in the summertime. And this, see, the temperature only goes up a little bit, and that shows temperature in the wintertime. And there's a big word of what makes up our temperatures, and it's the molecules. And I know that's a really big word for y'all, but I knew that you were so smart, and I wanted you to learn a little bit about molecules and how they affect our weather. So molecules are just what makes up the hot and what makes up the cold. I found a little video that I hope is going to explain it a little bit better than Miss Gina can. And so we're going to watch that, and then we're going to do a little experiment.
Experiment.
All right. Let's see, I'm going to present that here.
Come on now.
Atoms and molecules. Any object that occupies space and has weight is called matter. Matter is always found in three states: solid, liquid, and gas.
All right, so let's think about that. What is something that's solid? Just name something that's solid.
Mm-hmm.
Ice is solid. Very good. Ice is solid. What would be something that's liquid?
Go, Ari.
Hot.
So she said something that is liquid.
What's something that's liquid?
Hot.
Kinsey?
Water.
Water.
Yeah.
Oh!
Water is liquid. How about something that's gas? Mariah?
Cold.
Coal.
Xavier can't see, so if he wants to answer. So yes. When it's cold, we feel the gas in the air, and that's called the humidity, and it makes us feel cold. But yes, it's in the air. All right. Y'all got a good idea of that.
Matter is made of millions of tiny particles called atoms. Whether solid, liquid, or gas, an atom forms the basic unit.
So atoms are just what makes up the solid, liquid, and gas. What it's made out of. It's made out of atoms.
Atom comes from the Greek word atomos, meaning indivisible. The theory of atoms was put forth by ancient Indian and Greek scientists. However, this theory could not be proved because of the lack of technology. These tiny particles can only be seen through a scanning, tunneling microscope.
So they can only be seen by one of these machines.
Hmm.
It's the only way we can see an atom. So they're very, very, very tiny. There's all kinds of atoms floating in that water, but we couldn't see them. So if we had a microscope, we would be able to.
Microscope. The structure of an atom resembles an egg. The nucleus in the middle is like the yolk of the egg, and the orbits around it like the egg white. The nucleus has positively charged protons and neutrally charged neutrons. The orbits have negatively charged electrons. Two or more atoms combine to give rise to a molecule.
Okay, so if we have two or more of those teeny little atoms, it makes a molecule.
A molecule can be two atoms of the same element or a combination of different elements. There are 118 elements known to man. Imagine how many combinations of molecules can happen then.
Okay, so we're going to see how hot and cold molecules work. Okay, so first I'm going to talk about cold molecules. Cold molecules stay close together. Let me get my math, sorry. Cold molecules stay close together. And the way I remember it is when it's cold outside, I like to stay close to somebody. So when the water is cold, the molecules are real close together. But in the hot water, the molecules they move real fast. So I like to remember it. So when it's hot outside, I don't like to get beside anybody. I want to move away from them because they'll make me hotter. So that's a way to remember what a cold molecule is versus a hot molecule. Okay?
Turn around this way, baby.
So we have. Yeah, everybody get ready. Kenzie, turn your. All right. So we have some cold water. So who remembers if the molecules are close together or far apart in cold water? Are they close together or far apart in cold? In cold. Remember, we want to get
We close together.
close together because we're cold. So the molecules are close together, okay? Yes, yes. And the molecules, when it's cold, they're close together, so they don't go out into the atmosphere. There's not a lot of energy. So that's why it stays cold outside, because the molecules are real close together and they're not getting out there into the weather to make us warm. But when warm weather comes around, those molecules are bouncing all over the place and they're wanting to make us warm. So those molecules are they're not close together, they're far apart, okay? All right, so we're going to see what happens. What do you think might happen if I put this hot water in that cold water? Does anybody have any guesses what they
It will
think
be
might happen?
warm.
You better say so.
You think that's right. The water should get warmer. That's a good one. Let's see, I'm gonna put some. And if we have to do this again, we'll do it again.
It's like red jello.
Yeah, it does look like red jello, doesn't it? Okay. All right, so I'm gonna shave it a little.
That looks like a red.
Yes, it does look like a red drink. All right. So, does anybody else have any ideas of what might happen when I put this hot water in the cold water? All right, let's see.
Ginger ale.
But do you see? Can you see it's like a volcano?
Oh, yes.
Can you see?
It looks like a volcano.
Yes, those are
It's like a volcano erupting. Good.
And remember we said that the hot molecules move faster, right? So those cold molecules are holding that hot water real still because the cold water is cold, it's staying cold. But that warm water, it's moving fast. So it's getting out of that jar really fast. But that cold water's like, no, I want the weather to stay cold. You're not gonna warm me up. So you see? Oh, it's still working good. Yeah, it worked good the first time, so we don't have to do it again. Yay. See, so this is the cold water. You see, it's staying still. It's not mixing with those warm molecules.
Where's that cold water again, Miss Gina?
The cold water, this is the cold water that's clear. See where you can't see the red? That's the cold water. All this red is the hot water. And I'm going to tell you something that might be a little hard for you to understand. But last night, I had to get some help from a friend of mine to figure out how to do this experiment. And he was explaining to me, y'all, we have hot water heaters in our house. And I never understood why it's constantly filling with cold water. How am I getting hot water out? How is the cold water not mixing with the hot water and it coming out warm? Well, he told me that the cold water stays at the bottom because the molecules are close together and it's keeping that cold water at the bottom. But as the water's heating, it rises up just like this. So this is why when we turn our faucets on, this is why we get hot water.
Okay.
Is that crazy? Because I was like, how in the world can the cold water get in that machine and warm up just like that? But it doesn't. It stays at the bottom until it gets hot, and then when it gets hot, it rises up, and that's how we get our hot water.
Wow.
Yeah, so it's just like outside. Right now it's cold because the molecules are close together and they're not moving around very much. But whenever the temperature goes up, the molecules will go crazy and they'll just want to go everywhere.